Meta-objects? One model your database, your API, your UI, and your AI all share. Here's the problem it solves, and what it actually is. Today, when you build an app with AI, the AI writes every layer by hand. The database, the API, the forms, the prompts, even the docs. Each one a separate, hand-shaped artifact. They never quite fit, and every copy drifts. Meta-objects flips that. The AI writes one typed model, and from that single model, you either generate idiomatic code or embed the model live in your app to drive the server and the UI directly. One model, the whole app. Let's see that problem up close. Every app defines the same domain model a dozen times. It's in your database schema. It's in the validators that relist every field. It's in your API routes and their types. It's in the forms on the screen. And now it's even in your LLM prompt payload, and again, in every language you ship. Rename one field, and you chase it through all of them. And now an AI writes every one of those copies, faster than you ever could, with no guarantee they agree. The drift just got faster. And it's not just you. Forrester named it Agent Drift, the silent killer of AI accelerated development. Researchers studying AI coding agents found they overwhelmingly make small, local edits, not the system-level changes a human would. Practitioners call it prompt sprawl. Hundreds of prompts scattered across services, impossible to reason about as a system. And the academics are converging on the cause. The software model gets lost in code generation and has to be recovered just to make sense of what the AI wrote. So here's the cure, and it's refreshingly simple. You declare your domain model one time in plain readable text. Here it is, an entity called subscriber. Its fields, its identity, its constraints. This one typed model, not code and not a database, is your single source of truth. And from that one model, meta-objects gives you your whole stack. Your database schema, your API with validation and filters, your UI forms and grids, and your AI prompts in 5 languages. Now, you can use that model 2 ways. The first way is to generate code from it. A photograph of your model, perfect until something changes. The second is to load the model and drive behavior live at runtime. A live feed that just follows along. Both matter, and most teams use both. Let's start with generating. From that same model, meta-objects in its idiomatic code in every language. Here's your entity, the table, the validation, even a check constraint, all from those few lines. The same model also generates your DTOs, the typed payloads your code fills in, and your read-only views, derived, read-only, generated, entities, value objects, projections, all from the one model. And the generators are open. Need output we don't ship, you write a small one. Now, the 2 modes, side by side. Take your admin grid. You can generate the grid columns from the model, or drive the grid live. This is real. Shipping code, build grid walks the live metadata, the fields, their views, and returns your columns. No object or field names hard-coded. The same function renders any object. Same model. A photograph you regenerate when it changes, or a live feed that just follows. Your choice. Now the half most tools miss, and it's just as big as code again. Instead of generating, you load the same model into your running app and drive behavior straight from it. No code generation at all. It's how Salesforce runs the biggest apps in the world, and how Airbnb ships UI changes without an App Store release. There's no code gen path to a phone that already shipped, or an AI agent that connects tomorrow. A live model reaches them all. And the loaded model drives a lot. Dynamic create, read, update, delete, validation and relationships, server-driven admin grids that reshape the moment the model changes, your entities registered as LLM tools, prompt rendering, and tolerant extraction. This isn't just code gen and schema management. The runtime metadata engine is a pillar in its own right, and none of this needs a rebuild or a redeploy. Now, the AI itself. The moment your app calls an LLM, you add 2 surfaces nothing in your stack is checking: the prompt going in and the messy output coming back. First, the prompt, and it's part of the model. You declare a typed payload, the exact fields the prompt needs, and the text lives in an external mustache template that references those fields. The template can only use fields that exist on the payload. so a renamed field breaks the build instead of silently degrading the prompt. Then the output. Real model output is dirty. Prose wrappers, code fences, off vocabulary values. Metaobjects generates a tolerant extract function from that same declaration. It returns typed data with a report of exactly what it fixed, and it never throws. And one command ties it together. Meta-verify checks that your code, your schema, and your prompts still agree with the model, and fails the build if they don't. In a world where AI writes half your code, this is the guardrail. The AI writes the code. The model keeps it honest. And this is where the whole industry is heading. Let the AI author a model, not raw code. Google's A2 UI now has agents author the user interface as a declarative model, a data format, not executable code. But it's only the UI, and only a fixed palette of components. Andrej Karpathy calls it Software 3.0. We're programming computers in English now, and your prompts are programs that program the model, and that researchers are arriving at the same answer. Large language models that author models, not just code. Everyone is converging on it, each from a different slice. Meta-objects is the whole of it, shipping today. One typed, extensible, portable model. Your database, API, UI, and AI that you can drive live at runtime or generate code from in 5 languages. Not a roadmap, installable now. So that's meta-objects. One typed model, your database, API, UI, and AI all share. Drive it live at runtime, or generate the code in 5 languages. Go take a look. Everything's at metaobjects.dev. Thanks for watching.